These are solutions for the study guide for the quiz number 26. And so let's take a look at our first problem. Got a few different parts here. It says to find the mean, median, mode, and range for the data set. And we're going to explain which central tendency is the best describes the data. So I'll start with finding the mean. And for the mean of the data set, I just take the numbers 12, 10, 9, 15, 16, and 10 again, and I add them together, and I divide by how many numbers there are. So there's 1, 2, 3, 4, 5, 6 numbers, and so when I sum those values, I ended up getting 72. Dividing by 6 gives me 12. So 12 is the mean, and moving on to the median, I end up having to sort the numbers from smallest to biggest. So I'm doing 9, and I see a 10, another 10, and then 12, and then I see 15 and 16. So I'm going to recount, make sure I've got them all. And I've got 6 numbers, so yes, I do have them all. And so when I find the mean, or median is the middle number, I look for the middle number, and it's between two numbers. These are the two middle numbers, so the number I want is right in the middle between the two. Now this one's easy to see, that's 11. If the numbers were a little bit more difficult, like further apart, I would go ahead and add them together, divide by 2, and you can see how I'm getting 11 as the median. So the next one is the mode. The mode is the most frequent. So the one that repeats the most. And sometimes you'll see no mode if the no numbers repeat. Sometimes you'll see more than one mode if maybe 2 sets of numbers repeated. In this case, or maybe even more than that. And in this case, I have just 10 as the only number that repeats. So 10 is the mode in this case. The range is the difference between the highest and the lowest number. So I'm going to just subtract the highest number. 16 is the highest. 9 is the lowest, so I take away 9, and that gives me 7. So 7 is our range. And then they want us to know, actually in this case, 7 is the range. And in this case, I want to know what is the best description of the data. Well, looking at the numbers, I don't have an outlier. Since there's no outliers, no number that's really far from the data set, I'm going to say it's the mean. So we'll say the mean best describes the data because there is no outlier. So if there was an outlier, then I would pick either the median or the mode, depending on the type of situation. Typically, I'd go with the median. The mode I usually pick if I'm looking for the most popular, or if we don't have numerical numbers. So if it's just maybe A's, B's, and C's. So anyhow, in this next one, they're asking for what the value would be if the mean is 90. So it says your grades of 3 exams are 80, 93, 91. What do you need to get on the next exam to have an average of 90 on all 4? So what we're going to do is add up the numbers that we have, 80, 93, 91, and the number that we do not have yet, x. We're going to divide by 4 because we're eventually going to have 4 exams, and we want a 90%. So we're going to go ahead and do some opposite operations to undo this. So I undo the grouping symbol first, which is the fraction bar, by multiplying by 4. And what that gives me is the sum of these values, which sum to 264 when I add them together, plus x equals 360. So now I'll subtract the 264 from both sides, and I got to remember to borrow a bit, and we end up with 96. So you have to do pretty good on the next test to have an average of 90. And so on the next one, it says there are 14 girls and 20 boys in the class. If the teacher randomly selects a student, what is the probability that the student will be a girl? So we want the number of successes, so the probability of a girl. And so remember, our probability goes the successes over total outcomes. That is what the probability is. And so our successes are girls. There are 14 of them. So it's going to be 14 out of the total number of outcomes. It's going to be the boys and the girls added up. And so we still have 14, but it's over 34. And so when we go ahead and reduce it, taking out the common factor of 2, we end up with 7 over 17. And so if we went ahead and did some division, it'd be about 0.41 or 41%. So I would take it just as the fraction itself is fine. Let's take a look at the next type of problem that we'll see. And on this one, we've got a system of equations we're supposed to solve. So best way I see here, since these two are the same number but the same sign as well, I'm going to multiply 1 by a negative 1. And that'll switch all the signs. So this will become a positive 5y and a negative 31, or negative 30. And so I go ahead and do the subtraction. The 1/2 will cancel out. We're left with 12y equals, and again, this is 30 here, so I subtract these two numbers, and that gives me negative 24. Well, when I divide by 12, I get y equals negative 2. Take the negative 2, substitute it back in. Doesn't matter which equation, I'll pick the top one. 1/2 x minus 5 times negative 2 equals 30. So 1/2 x plus 10 equals 30. Well, when I go ahead and subtract the 10 from all sides, I'm left with 1/2 x equals 20. And then multiplying by the reciprocal will cancel out that fraction, and I'm left with x is 40. So 40 comma negative 2, that's where the two lines end up crossing. So moving on to the next one, I use substitution on this one. Y is by itself, so I'm going to plug this expression in for y. So I've got 6x minus 2, and then I've got to double what y is. The 4x plus 1 is what y is, equals negative 3. I distribute, left with 6x minus 8x minus 2 equals negative 3. So I end up adding 2 to all sides, and I get negative 1 equals negative 2x. So when I go ahead and divide by 2, I've got the answer. So it's going to end up being negative 1/2 is the value of x. And now I'm going to go ahead and substitute. And actually, it's going to be a positive 1/2 because I divided by negative 2 on both sides. So go ahead and change that right now to a positive 1/2. So from this point, I can take that 1/2, plug it back in. This x on the top equation would probably be the easiest. Y equals 4 times by a 1/2 plus 1. So 1/2 of 4 makes 2. 2 and 1 make 3. So y is 3. So 1/2 comma 3. That's where the two lines end up crossing. So on this next one, we'll do the same thing. Use substitution. Great method when y or x is by itself. So I got 3x minus 3x plus 2 equals 6. So I go ahead and solve for x, but notice what happens here. 3x minus 3x makes 0. 0 and 2 do not equal 6. And so when the numbers do not equal each other, all variables are gone. What this means is there is no solution. No solution because the lines are parallel. They have the same slope. And whenever they have the same slope, we're not going to get two lines to cross. Well, looking at the last three problems, we got another one here. This one I'm going to go ahead and use substitution and plug it in here. I've got 2x plus negative 2x plus 3 equals 3. So the 2x and the negative 2x cancel each other out, and it doesn't equal 0, it equals 3, so let me fix that. But as I was saying, the 2x and the negative 2x cancel each other out, and we're left with 3 equals 3. And this is an identity. But that's not the answer I'm looking for. That's what it is. It is when you go ahead and have two numbers equal each other. So what their answer is, though, is this. We have infinitely many solutions. We have infinitely many solutions because, and I could go with two answers here, because the equations, or you could end up saying lines, I would take that either equations or lines are the same. So we have the same exact equation. Last time we had the same slope. Here we have the same exact equation. You can see it. If you move this 2x over, you'd have y equals negative 2x plus 3, the same exact equation you have up here. So on the next problem, that is the answer right here. The next problem, it gives us the distance between Los Angeles and New York is 3,000 miles. Jet flies from Los Angeles to New York with a tailwind. Okay, tailwind means it's pushing you. There's two components to the rate. And then it does this in 5 hours. So let's just start with that. Distance equals rate times time. So it's 3,000 miles, and it's being pushed. It's got the rate of the plane plus the wind. So when it's a tailwind, that means that we're adding the wind speed to the rate of the plane, times by 5 hours. And R stands for plane speed, and we'll say that W stands for wind speed. And so from there, I set up the next one. It says the return trip. Return trip means same distance, 3,000 miles, equals, but this time going against the wind. So against that same wind, R minus W. And we do this for 6 hours. So what I'm going to do, instead of distributing the 6 and the 5 over this addition and this subtraction, I'm going to multiply by the reciprocal, and that will cancel out those 5s here and cancel out the 6s. But you got to do the same thing on this side as well. So it just makes the problem a little bit easier. So when I do that, I'm left now with a fifth of 3,000 is going to be 600 equals R plus W. And on this side, a sixth of 3,000 makes 500. So 6 goes into 35 times, 5 goes into 36 times. And this is equal to R minus W. So now I can just add the two equations, and I'm left with 1,100 equals 2R. Common mistake is people just put R, but you got to add 1R and 1R make 2R. So dividing by 2 gives me 550 miles an hour. That is the rate of the plane in still air. And it says find the wind speed as well. So I'm going to just substitute it into one of these equations, actually one down here. And so I have 550 plus W equals 600. So subtracting the 550 from both sides gives us a wind speed of 50 miles per hour. So looking at the next problem, it says two cars leave town at the same time going in the same direction. Okay, so here's what it looks like. So we got one car going there, and same time, same town. So the other car goes a little faster. And so I know that because it says one car is traveling at 30 miles an hour, the other is at 46. When will they be 72 miles apart? So this distance is 72 miles. So let's go ahead and set up our equation. Distance equals rate times time. Well, we know the rate, we don't know the time, but we know it's the same time. Same time. So I'm going to write 30t, and I'm going to write 46t. Now the distances are different. So I'm going to say that the distance the slower car went was d miles. The distance the faster car went, well, it went those d miles and 72 miles. So that's the difference, is because they are 72 miles apart. So I'm going to write d plus 72. So now, once I have the equations, I go ahead and substitute 30t in for d in this equation down below. And I rewrite what I've got. So I've got 30t plus 72 equals 46t. So I'll go ahead and subtract the two distances, or two rates, that is. Rates and times, rates multiplied by times. So 72 equals 16t. Divided by 16 gives me my answer. So in this case, it's going to end up being, that reduces down to 9 over 2, which ends up making 4.5 hours. That's how long it's going to be until they are 72 miles apart. So those are the problems that you're going to see on this week's test. Good luck.